Okay, so today we're going to look at stationary points. So just a reminder from last year, if you've got some function, and let's draw the function in, say it looks something like that, then a stationary point's any point where the gradient is 0. So we'd have a stationary point here, a stationary point there, and if I've drawn this correctly, stationary point here. Now, we've got different names for them. We're not going to worry about that too much, but this is a local max, a local min, and this is a saddle. And a saddle could also come from the top, flatten out, and then continue downwards. Okay, so how do we find the stationary points? Well, where the gradient equals 0, that means that our derivative has to equal 0. So for this one, find the stationary points of y equals x cubed minus 3x minus 12. I want my gradient to equal 0. So I'm going to do dy dx, find my gradient, so 3x squared minus 3, that disappears, and I want that to be 0. So I got 0 equals 3x squared minus 3, and then I just want to solve it, so adding 3 to both sides, dividing by 3, and then finally I just want to do a square root. So x equals square root of 1, which is just 1. But remember, I need a plus or minus 1. So I've got two stationary points. One's at x equals plus 1, one's at x equals minus 1. Now, it does say the points, so I really do need to put them back in. So for x equals plus 1, y equals 1 cubed minus 3 times 1 minus 12. That looks like minus 14. So the point would be 1 comma minus 14. And the other one, minus 1, then I've got y equals minus 1 cubed is going to be minus 1. Minus 3 times minus 1 is plus 3. Minus 12. That looks like now it's going to be minus 10. So the other point is minus 1 minus 10.